Test B. So this is velocity in meters per second, and the time is in seconds. So if we take the width, if seconds, times the height of meters per second, the seconds cancel and we get the units to be meters for our answer. And if we're supposed to do right 6, we're supposed to have 6 different columns. So one column would be go from 0 to 4, 4 to 8 is a second, 8 to 12, 12 to 16, 16 to 20, and 20 to 24. That's 6. And if I'm supposed to use the right, then I'm going to go to the height at 8 of 8, because that's on the right side. So the width is 4. Every one of these is 4, so I can take 4 times. The right side of this one is 8. The right side of this column is 10. The right side of the one between 8 and 12 is 12. The right side between 12 and 16 is 20, high. And between 16 and 20, the right side is up at 22. And the right side from 20 to 24 is up at 25. So I have 4 times 97, which is 388, and this would be meters. Now if I do left 6, same columns, same spacing, 4 wide, but I got to use the left side, so I'm going to use the 5 instead of the 8. 8 on the right side, 5 on the left. For the first column. For the second column, the 8 is on the left of that one. So I'm going to use that 8, and I'm going to use the 10 for the third one, and I'm going to use the 12 on the left side of this 12 to 16, and then I'm going to use the left side of 16 to 20, which is 20, and then I'm going to use the left side of 20 to 24, which is at 22 high. These are, width is in seconds, and these are in meters per second. The seconds cancel, so I get meters for my answer. So I have 4 times 77, which is 308 meters. Now midpoint 3, it's a good thing I chose 3 because otherwise I'd have trouble. Which means I have to have a midpoint and I have to have 3 intervals. So my interval will be that size, and that size. And the midpoint of this one, the height is 8. And the width is 8. So I'm going to take the width is always 8. So I'm going to take 8 times the height in the middle, 8. The height in the middle of this one is 12. And the height in the middle of this one, the height is the 22. And again, this will be in meters because it's seconds times meters per second. And so I get 8 times 42, which is 336 meters. Then T6. Now, I could do it the long way, which is divide it in 6 intervals, then each one would be 4. And trapezoid, I'd have to do the average of 5 and 8, so I do 5 plus 8 divided by 2, plus 8 plus 10 divided by 2, plus, and so on, all the way up to 22 plus 25 divided by 2. But this works out to be the same math as doing the average of right 6 and left 6. So I could also just do 388 plus 308 over 2, which comes out to be 348 meters. Okay, number 2. Now we're supposed to determine what's the low on this. Well, if it's decreasing, then if I make rectangles down here, the right side on it will get the low. So I'm going to do an R4. I got to determine the value from 1 to 3, not 0 to 4, not 4, and anything, 1 to 3. The N4 means split it into 4 pieces. Well, that lands right on these halves. 1, 1.5, 2, 2.5, 3. Makes 4 columns. And I want the right side to be an underestimate. I want to go to the curve and on the right side. On the right side, it's about there. The right side, it's about there. On the right side, it's about there. Each one's a half wide, so I'm going to go 1/2 times, let's see, the first one's about, I don't know, 3.7, 3.6 maybe. Next one is about 1.9. The next one's about 1.3. And the last one's about 1 or 1.1. Which comes out to be 1/2 times 8.0, I believe, which is 4. That's a rough answer. And these are estimates. And why is this the low? Well, I could either explain that each of these rectangles are below the curve, completely below the curve, and leaving out some. Or I could say on a decreasing curve or function, R's right Riemann sums will all be below the curve. Something like that. Okay, number 3. So the snow is falling on the patio, and it says it's keeping track of it. This is keeping track of it after 12 o'clock noon. So all these times are, if they're not over 12, will be PMs. So I need to make sure I include the PMs in my answers. So this says the amount of snow at 5 is 8 inches. The amount of snow at 3 is 6 inches. This amount of snow at 9 p.m. is 18. And this tells the change. So between 7 p.m. and 9 p.m., there was 2 more inches fell. And between 1:30 p.m. and 5 p.m., 5.5 inches fell. So that's what we have to work with. So now we've got to come up with how much snow, and say it's in inches or whatever it is, and explain what it means relative to this 12 noon and the snow on the patio. So this will be how much snow was there at 7 p.m. Well, here has 7 to 9. It gained 2 inches, and at 9 it was 18. So if we back off the 2 inches, there would have been 16 inches of snow at 7 p.m. And you can write in the 18 minus 2 if you want. That'll help me know how you got your answer. This says how much snow fell between 3 p.m. and 7 p.m. Well, at 3 there was 6. At 7 we just figured out there was 16. So that means 10 inches of snow fell between 3 p.m. and 7 p.m. Next says, how much snow was there at 1:30? Well, 1:30 is on this one. 1:30 to 5, 5.5 inches fell. Well, at 5 there was 8 inches. So if we back off the 5.5, so 8 minus 5.5 is 2.5. So how much snow was at 1:30? 2.5 inches of snow. You can include on the patio if you want. At 1:30 p.m. And finally, how much snow fell between 5 and 7, and divided by the amount of hours that was, 7 minus 5, 2 hours, we're going to be finding out the amount of snow per hour. So 5 to 7, see, at 5 there was 8 inches, at 7 there was 16 inches, so 8 to 16, that's 8 inches. 8 inches fell in the 2 hours, so we get 8 divided by 2, 4 inches per hour equals the average rate of snowfall between 5 p.m. and 7 p.m. That does not mean that it fell 4 inches in the first hour and 4 inches in the second hour. It could have been 8 inches fall in the last 10 minutes and none the rest of the time. And it would have had an average of 4 inches in the 2 hours. Okay. This says, oops, this one doesn't show this problem here, so I'm going to have to find B. What was it? Somehow this didn't show up. So this one said 0 to 5 of f of x dx. This said from negative 5 to 5 of f of x dx. And this one said 2 to minus 5 of f of x dx. Okay, even function. That means it's symmetric with the y-axis. So whatever happens on the positive side of the y-axis is the same on the negative x side of the y-axis. So between 0 and 2, it was minus 6. Between 0 and 2, it's minus 6, which means over here it's minus 6. And between minus 2 and 5, there's a total of 4. Well, we have minus 12, so there must have been 16 here to come out with 4. And since it's symmetric with the y-axis, that means there was 16 there. So, how much between 0 and 5? Minus 6 plus 16 is 10. Between minus 5 and 5, well, there's 10 here and 10 here, so that's 20. And between 2 and minus 5, so that's 16 minus 12, which is 4. But I went backwards. I didn't go from minus 5 to 2, which would be 4. So this is minus 4. because the limits are backwards. Okay. So number 3. Now this one's going to be power rule, and a trig rule. So x to the 2, you increase the power by 1, makes it 3, and divide by the 3, so the 3's cancel, so I get x to the 3rd. Or if you will, you take the derivative of this, it becomes 3 times x to the 2, which is what we had. And then it's minus, and then this is x to the 1/3, so if I increase that by 1, it becomes x to the 4/3, and I have to divide by 4/3, which means multiply by 3/4. And see, and cosine is the derivative of sine, so this is going to be plus 5 sine of x. And since they want the general antiderivative, I have to go plus c. This one, well, this is a quotient. To undo the quotient is tough, but since it's a single term down here, we can bring it up. Now this is the same as x to the 1/2 in the denominator, but if I bring it up, it becomes x to the minus 1/2. And if I distribute it, when I multiply, I add the powers, so 2 plus a negative 1/2 is x to the 3/2. Then I have minus 7, and then I have times x to the minus 1/2. Now if I use the power rule, here I've done some algebra to rewrite this. Now I'm going to use the power rule. So if I add 1 to 3/2, I get 5/2. And if I divide by 5/2, that's the same as multiplying by 2/5. So that's for this part. Minus, and if I increase minus 1/2 by 1, I get plus 1/2. And if I divide by half, that's the same as multiplying by 2/1, so I get 2 times 7, or 14x to the 1/2 plus c. And this is the square root of x. This is x squared times the square root of x, if you wanted to. Now this one, some of you tried to just take the antiderivative of the numerator and the denominator. It does not work. It's a quotient rule. But it's also just 5 and 3, so it's 5/3 times 1 over x squared, or 5/3 times x to the minus 2. So the antiderivative, we'd add 1 to this. The only time we wouldn't do that is if it was minus 1. So we add 1 to this, and we get x to the minus 1. And we'd have to divide by minus 1. Well, 5/3 divided by minus 1 is minus 5/3. Or you could write it negative 5/3 times 1 over x. Now, some people said, oh, 1 over x, that's ln x. Well, we already did the antiderivative. You don't want to do the antiderivative again. So you're done there. Now this one, if you didn't know your derivative rules, you wouldn't recognize this one. But this is 7, and that would be times 1 over x squared plus 1. And hopefully you have that in your notes, that that's the derivative of the arctangent of x, or tangent inverse of x, times a 7. The constant pulls out, and so we get this. And this one, the antiderivative of cosine is sine. Antiderivative of secant squared is tangent plus c. Now this one, we're supposed to evaluate these definite integrals, have limits, exactly. So I don't want decimal approximations. I want it exactly. X to the minus 1 is 1 over x, so that becomes ln absolute value of x, and the antiderivative cosine is sine, so that's negative sine x, and we've got to evaluate that, so we put the limits at the end of this from 1 to 2. So we put to 2 in, and the absolute value of 2 is 2, so I can drop the absolute value, so I get ln 2 minus sine of 2, and better be in radians in your calculator, if you're going to use your calculator, minus, and then you put in 1, and ln of 1 is 0, so I don't have to have that, minus sine of 1, and that's the exact answer. Now you could change this to plus sine 1, minus minus is plus, but if you put this into your calculator and get the decimal approximation, that's a nice way to check this, and you can type this into your calculator and do the second calculate the area. But this is an exact answer. I want the exact answer. Now this one, x minus 2, that's a slope of 1 going through minus 2. If it didn't have absolute value, minus slope of 1 would look like this, where that's 2, that's minus 2. And we're going out to 5. But the absolute value takes this part and makes it up here, flips it over. So, if we're doing the antiderivative of an absolute value, any part that's negative, we have to change the sign on. So, we would have to go from 0 to 2 of x minus 2, but that would be negative, so I'd have to change the sign. Plus, and then for the rest of the way from 2 to 5, we can do x minus 2, and that will be positive, and so I don't need to change the sign, so I can leave it plus. Now the antiderivative of x is 1/2 x squared. Add 1 to the power and divide by it. And the antiderivative of minus 2 is minus 2x. And we have to do the negative of that, evaluated from 0 to 2, plus that's this antiderivative, what I had before, 1/2 x squared minus 2x. Don't change the sign. Evaluated from 2 to 5. And so we get 2 in here, we get 4. Half of 4 is 2, so we get negative 2. 2 into there is plus 4. Minus, and putting 0 into this, I get 0. Plus, putting 5 in there, I get 25 halves. Putting 5 in there, I get minus 10. Minus, putting 2 in there, I get minus 2, or I get 2 minus 4. So, 2 minus 4 is 2, and this is 2 minus 4 is minus 2, and a minus is plus 2, so I got 2 plus 2, which is 4, and then I have 12.5 minus 10, which is 2.5, so I get 6.5. This original 2 was this area right here, and these together is 4.5, making the 6.5. Now this one, pi is a constant, like 5. the integral of 5 is 5x. The interval pi is, the antiderivative of pi is pi x. And the antiderivative of negative x e to the x is negative e to the x. And we have to evaluate it from 4 to 2, which is backwards, so we're probably going to get, if this area is negative, we'll get a positive. If the area is positive, we'll get a negative. But we don't really care at this point. We just got to do it. So we put in the 2, and we get 2 pi minus e squared minus 4 pi minus e to the 4th. Now that's an exact answer, and that would be good. Even better is if you could combine like terms, like 2 pi minus 4 pi is minus 2 pi. These are not like terms, so you can't combine them. Minus e squared plus e to the 4th. Minus and minus. Okay, last page. So this is the derivative of this, so we have to take the antiderivative, and the antiderivative of this, so 1 raised to 2, and divide by 2, that would be t squared, and 2 raised to 3, divided by 3, so the 3's cancel, so minus t to the 3rd, plus c is the antiderivative in general for f of t, capital F of t. But it says if we put in 2, we'd get 4 minus 8 plus c, but it's supposed to come out to be minus 5. So what would c have to be? So this is minus 4, and so this would have to be minus 1 to get minus 5. So my final answer for f of t is that it has to be t squared minus t to the 3rd minus 1 to make this work. Okay. Velocity in meters per second, and this is in seconds, so the area would be meters per second times seconds, so it would be meters. And if it's moving to the right, if it's positive, well, this is negative area, so it's moving to the left, and then it moves to the right. And we're supposed to go up to 16, which is here. And we're supposed to find out where it's at. Well, it's negative area and more positive area than negative, so it will be on the right. But let's see how much. Now you could count squares. Let's see, a square is 2 wide and 3 tall, so that's minus 6 is how much that square is worth. Or you can use triangles. Let's see, if this goes from 0, 1, 2, 3, 4, 5, so it's 5 by negative 15, so that's negative 75 if I multiply those. But that would be for a rectangle, in half of that for the triangle. And this is also 15 by 5, and so this is positive 75 halves. And this side is 15, and this side is 6, so the average of 15 and 6 is 21 divided by 2 times the width, which is 2, 4, 6. So the 2 goes in 6 and leaves 3 times 21, which is 63. So this area represents a change of 63 meters. This is 75 halves, or 37.5 meters, and minus 37.5. So the total position change, it goes backwards 37.5, forward 37.5, and then, so I'm back where I started, and then I go 63 more, so I'm 63 meters to the right, to the positive. Determine the total distance. All right, so now I'm not going to do half, or the negative. So half of 75 plus half of 75 is 75. So total distance here is 75 plus 63, which is 138 meters it traveled. Most of it to the right, some of it to the left. But we don't have to say that. All right. 9, we're supposed to go from -2 to 4. So -2, -1, 0, 1, 2, 3, 4. The minuses are a little tricky here. So we got 1 minus 2, which is -1. And -2 squared is 4. So we got -1 minus 4, which is -5. This minus is not squared, but the -2 is. Now the -1 squared would be 1, so we got -1, and we got -1 for that, and a 1, so we get a total of 1 minus 1 minus 1, which is -1. If I put in 0, those are gone, and I get 1. If I put in 1, I get 1 plus 1, which is 2, and 1 in here is 1, so 2 minus 1, which is 1. If I put in 2, I get 3 minus 4, which is -1. If I put in 3, I get 4 minus 9, which is -5. And if I put in 4, I get 5 minus 16, which is -11, which comes out to be, make sure I'm doing this right here, -21. And finally, this one. Some of you did all kinds of strange things. Didn't recognize this as 2 squared, 3 squared, 4 squared, 5 squared, 9 squared. So it must be something like I starting at 2 and going to 9 of I squared. Or if you will, if you did I starting at 1 and going to 8, because there would have been 8 terms, and I plus 1 gives you 2 for the first one. Squared is 4. Then when it's 2, we get 3 squared, which is 9, etc. And 8 plus 1 is 9 squared is 81.